And we are recording. So tonight I want to introduce our speaker, which is Bob Pusateri. Most of you probably know him because he is local to the area, and he used to be one of the leaders of the Chicago SQL Server User Group. Tonight he's going to talk about Azure Data Lake. It's a really cool thing. So hopefully you're here to learn something new or learn something more about it if you're already familiar with it. And Bob is a Microsoft certified master, an MCM, a Microsoft Data Platform MVP, a Microsoft certified trainer, and over 15 years of experience with SQL Server. So I will hand it over to, oh, and I should mention his Twitter handle is @SQLBob. So, and he blogs at bobpusateri.com. I will let him take it from here. Go ahead, Bob.
All right. Thank you so much, Jared. Everybody, you can see my screen, right? I'm assuming people can see my screen. I'm hoping so.
Sure can.
Okay, awesome. Thank you. All right, so yeah, welcome to dipping your toes in Azure Data Lake for DBAs. As Jared said, this is a really cool offering, but it is quite different from, if you're coming from a relational database background or you've been a DBA for a few years. It's a different way of thinking of things. So this is really an introductory session to kind of walk through what exactly it is, how you can leverage it, and how you can play around with it on your own a little bit if you like. Jared introduced me pretty well. Probably the best thing on this screen is all the contact information. So yeah, you can find me on Twitter at SQLBob. You can email me at that address, bob@bobpusateri.com. You can check out my blog, and you can see that I haven't posted anything in like 2.5 months because I've been so busy. I haven't had time to write any blog posts lately. And I will have all this contact info at the end as well if you'd like to see it again. So tonight we're going to talk about what exactly is Azure Data Lake, and then we're going to dive in a little bit and talk about data lake storage, how you go ahead and process and work with data that's in data lake, some considerations you might want to take for designing the layout of data in your data lake. We'll talk briefly about some DBA topics, and then because it is a cloud offering, we'll talk about cost at the very end. And these slides, the price may have changed since I wrote these slides. Did not look at the last slide to see, so we'll find out together. But we'll start off by talking about data, right? And data is a whole bunch of things these days, right? You can have data that's like about your customers, or maybe data is about your business, or maybe just your business is, data to begin with. Your business is in the business of selling, distributing, maintaining data, etc. Data has value, right? And it's valuable to us. It's valuable to others, which is probably why your business exists to begin with. Because it has value, some people say data is, flat out the new currency, right? And if we're talking about currency, well, then we need somewhere to store that currency. And if, depending on how much currency you have, if you have like one person's worth of currency, maybe a wallet or a purse made out of seatbelt material would help you hold that. But if you got a whole lot more currency, now you're talking about something bigger and more impressive, right? So got a lot of currency, have somewhere to put it. And similarly with data, right? Big data, big databases, and then we get to the point where maybe not everything goes in a database anymore, and that's where data lake can really come in. So similarly, with how SQL Server can't do everything, right? SQL Server can do a lot of things, and they keep adding awesome features all the time, right? Like 2019 big data clusters. But we have a complementary product as well, which can work very well with SQL Server, and that is Azure Data Lake, which Microsoft has represented by the can with water on it, showing it's a lake. So what exactly is that data lake? If we were to go by the official definitions, it'd be a scalable platform for housing all kinds of data for analysis, or a repository for analyzing data in its native format, and that's a real key feature there we'll talk about. But to boil it down, it's a scalable storage system with a lot of helpful tools. And again, storage system I have underlined there because that's really important. Data lakes are designed to work with lots of different services and sources, right? And really enable self-service. So you have all kinds of data you can put in your data lake. You can put image data, you can put, streaming data from the web, social media data, all this stuff in its native format, and then take it out and work with it and analyze it in a whole variety of tools, right? We got Databricks, we got Synapse Analytics, we got Power BI, we have other tools like Hive. There's a bunch of tools that Data Lake will work with. And because we're storing this data in its native format, we don't have to transform that data to put it there, right? I used to work in healthcare, and we had lots and lots of healthcare data that we had to load every day. Some of it was from relational systems, some of it was from non-relational systems, but we had lots of processes, most of which were written in SSIS, that did nothing but load this data all day or all night. We had an entire team dedicated to writing processes that loaded this data and fitting this non-relational data into the relational format necessary for SQL Server. A lot of this data probably could have gone into a data lake in its native format, and we would have been able to just work with it just fine. Unfortunately, data lake technology wasn't really anywhere near where it is today at this point, but that would have been a very viable solution, at least in this day and age. Data Lake is designed to be very performant, scale linearly and infinitely on demand. It supports a whole bunch of access patterns because it's designed to work with all kinds of tools that can handle pretty much anything you can throw at it. It's designed to be securable. It's got access control lists, groups, and principals, so you can get really granular with your security. It has a whole bunch of APIs as well. Pardon me while I start coughing. Has a bunch of APIs for management and access by a variety of different products, as I've talked about. A very key point again is that Azure Data Lake is storage. So it is very much a bring your own engine model. So when we're talking about SQL Server, SQL Server has a whole bunch of stuff, right? It has a great storage engine, but it also has a query optimizer, a query processor. We tell SQL Server, hey, give me this data, write this query, and it will go figure out, okay, I need to fetch this data and do A, B, and C to it to return to you what in the format you asked for it. Data Lake is only the storage part of that. If you want to do any kind of processing on that data, you need to bring your own engine in the form of a different tool, which again, there are many. There's Databricks, there's Spark, Power BI, SQL Data Warehouse, Azure Synapse Analytics now. There's tons of things, but Data Lake itself has no compute or query processing. It is purely a storage system. And we'll hammer that again a couple more times. But all in all, it is a great tool to have in your toolbox. You may be doing some work very similar to a data lake already if you're using like SSIS, like I said, or if you have doing archiving or tiering of your data. This is all things you can accomplish similarly in a data lake as well. And if you spend a lot of time writing integration services packages to load data to make your data fit into a certain format, you may want to pay attention during this session and see maybe a data lake could help you that way. So what do we put in a data lake? And for purposes of this talk, we're going to talk about structured versus unstructured data. Essentially, for tonight, at least, anytime I say structured data, we're meaning relational data. Right now, relational data has a very, very rigid structure based on a relational model that we've defined. The unstructured data, the stuff on the left side here, it does have a structure, right? I mean, I'm talking about CSVs, JSONs, XMLs, JPEGs, PDFs. All these files have structure, right? They wouldn't be a defined file format if they didn't. But collectively, this is often known as the big data, right? It's non-relational data. We can certainly parse it and make sense of it, but not in the same way we work with relational data. We need some extra tooling to make that happen. But this is all wonderful material for a data lake. Big data itself is often known as having 4 V's, right? And these are volume, variety, velocity, and veracity. Some would also say there's a 5th V for value, right? If we're not creating value from the other 4 V's, then why are we dealing with this data to begin with? But all data has structure, and we have the data lake is really designed to tackle the volume and the variety, right? It can also handle velocity and veracity as well, but different types of data in native formats that we can make heads or tail of with a variety of different tools. Being that data lake is a storage system, we should probably get to the meat and potatoes and talk about exactly what that means. And it is, of course, storage in the cloud, and there's a couple different flavors of storage in Azure. So we're going to cover them kind of briefly here. The first is Azure Blob Storage, or WASB, for Windows Azure Storage Blobs, right? This is optimized for unstructured data, like video, images, files. It is a flat store. That's why it's called blob storage. So there is no folder tree. And I've got an asterisk next to that because if anyone in the audience has ever actually worked with Azure Blob Storage, you've probably seen a folder tree. It will display one for you, but it doesn't really exist. It's kind of virtual. So if you were to like create a folder in Azure Blob Storage and put some files in it, they're not really in that folder. Basically the file name has the folder name at the front of it is how it works. And you can totally see that this is a virtual presentation of a folder, because if you delete all the files in the folder disappears too. It's not like NTFS or any other structured storage system where you can create a folder and have it be empty. There is no such thing as an empty folder in Azure Blob Storage because the folders didn't exist either. Important things to know about Azure Blob Storage: it's really cheap. It's the lowest cost. We'll see when we compare prices that it's pretty low. It's really low. It is a tiered storage system, so you can specify what level of redundancy or performance you want, and the cost will vary accordingly. But this is a great place to store data of virtually any type. I use Blob Storage personally. I keep all my photos, all my videos. I have a massive Azure Blob Storage account. I use the archive tier. It's really cheap. It's like 99 cents per terabyte per month right now. So, I get a bill for like less than $1 every month, and I have all this data stored really securely far, far away in an Azure region. So you can define what level of redundancy you want in Azure storage, and there's a couple different settings of redundancy. There's locally redundant storage, where there's multiple copies, but they're in one data center, which is great unless the data center goes offline, in which case you might want to do something different. So there's zone redundant storage, where the data is stored in a zone. It's in multiple zones within a single region. So there's separate data centers. So any one single data center going down will not cause your application to be interrupted or your data to be lost. If that still doesn't sound good enough, if your needs are more critical, we have geo-redundant storage, where your data gets geo-replicated to another region automatically. And if the primary region happens to go down for whatever reason, your endpoint will just redirect to the second region. If you go to my blog and look at anything on my blog, all the images on my blog are actually hosted in Azure Blob Storage in a geo-redundant storage account. And they've never had issues in all the years it's been there. And then finally, there's also read access geo-redundant storage. So this is where you can have your data automatically replicated to another Azure region, but you get a second endpoint and you can read from that second region as well. So you get two endpoints in that point. But you can choose, when you create a storage account, what level of redundancy do you want. Similarly, you can choose your storage tier. And this is essentially how frequently is your data accessed and what level of performance do you need. If you have, if this is online data that's going to be accessed all the time, needs to be available very quickly, hot would be the storage tier of choice. You'll pay the most to store it there. It's still not much, but it is the most expensive of the three. And you'll pay the least to access that data. If this is data that you don't need to access very frequently, this data in the cool tier, but it costs a little more every time you access it, and it has a minimum 30 days. So basically, if you put a file or an object into blob storage in the cool tier and you delete it before 30 days, you end up getting charged as if it was there for 30 days. It's kind of their penalty to show you that, hey, this is something that's supposed to be here for a longer period of time. And finally, we have archive storage, which is the lowest cost. This is also known as glacial storage, comparable to Amazon Glacier. So if you want to retrieve something from archive storage, it usually takes on the order of hours to retrieve it. But it's very cheap to store it there. But the idea is this is not data that you would ever have available to others immediately. This is something like your backup of your backup copy, where it needs to be kept safe and safely and inexpensively, but we're not going to need it on a moment's notice. If we have to go get this data, something really bad happened, or ideally you'd never get that data to begin with. And it comes with a 180-day minimum. So this is Azure Blob Storage and the options you get in terms of performance and redundancy. Okay, so hold the thought on Blob Storage. And we're now going to talk about actually Azure Data Lake Storage Generation 1, because there's two generations of Data Lake. The original one was called Azure Data Lake Storage, or ADLS. It's now known as Generation 1 because there is a Generation 2. And this was built to kind of have some more features than blob storage. For one, it was designed to have a real folder structure. There is an actual hierarchical structure in ADLS, unlike in blob storage where the folders are kind of virtual. In ADLS, you get real folders, so that's cool. There's also no file size limit in ADLS. There is a limit in blob storage, and they actually just raised it like a month or two ago. So I want to say it's like, isn't it like 200 or 300 terabytes per file now in blob storage? There's still a limit, but it got way bigger. It used to be like 5 terabytes per file, and they made it huge. So there's technically a limit in blob storage, though if you're approaching that limit with any single file, you probably have other issues at this point. It's performance optimized for analytic workloads. It has access control lists, Azure Active Directory integration, and it was designed to work with MPP, right? Massively parallel processing platforms. So this was Azure Data Lake Generation 1. And that was around for a few years, and then they came out with Azure Data Lake Generation 2, or ABFS, for Azure Blob File System. And the idea with this is, this actually makes use of an Azure Blob storage account. So if you'll notice in the little screenshot I have on this slide here, this is just looking at one of my accounts in the Azure portal. And you'll see here under resources I have provisioned, I have a Data Lake Storage Generation 1 provisioned, and that is literally a type of resource in Azure. So you go to Azure portal and you say, I would like to create one Data Lake Storage Generation 1, please, and it will go ahead and give you a Data Lake Storage Generation 1. ADLS Gen 2 is not a resource type. It is basically a file system you write onto a blob storage account. So you actually go ahead and you just create a blob storage account, but then you check the box that says make this an Azure Data Lake Generation 2 account, and it'll actually put that file system onto the blob storage account. Now, because it is a blob storage account, you get all the features of the blob storage account that we talked about at the beginning. But you also get the actual file system, you get folder structures, you get atomic operations, you get even more features than you did in Generation 1, and you get the price advantages of blob storage because it's a blob storage account. So you kind of get the best of both worlds there. You get the features of object storage or Azure Blob Storage, and the best of Azure Data Lake Storage Generation 1 in Generation 2. Now, you can still provision Azure Data Lake Storage Generation 1 counts at this point. I personally would not. I don't know if Jared or Amina have a opinion on that, but my understanding has been, especially for anything net new at this point, create a Generation 2 account. Only real reason you'd want to create Generation 1 is if you had something existing that actually required Generation 1 at this point. Generation 2 has been out for several years now. I can't remember the last time I created a Generation 1 account other than to mess around with a feature, with to see how Generation 1 would react to something. So that's kind of how the storage works. Let's talk about files for a minute here. So as I said before, when I was talking about like big data file formats, a lot of these files are going to end up being some form of text files, right? Maybe a straight text file, a CSV file, right? These are very, very standardized and well supported, and pretty much any data product that's worth its salt is going to be able to read a text or a CSV file, right? If it can't do that, I'd start running the other way pretty quick. We also have JSON in there, right? JSON's great. It supports some nesting. It's human readable. You can have, files get a little larger in JSON because you have tags and nesting and stuff and brackets to put in there, but it's still better than XML where you had to duplicate every bracket every time, right? That was the big idea with JSON to begin with, was, hey, you get the nesting of XML, but save a little space on the tags. These are probably the big three text formats at this point. But from there, we get some more interesting file formats too that you commonly see in a data lake or in a big data setup. One of them is called Avro. And Avro is a two-part file format. So it actually has a schema portion that's a JSON part of the file, and then it has a binary portion that the data is in. This is a little more efficient because the data is in a binary format, right? You don't have the overhead of just being a text file. And because it does store its schema data, you also get schema evolution with that. So if your schema is changing over time, you can actually have that reflected in the schema portion of the file, and the data wouldn't have to change. Probably the biggest downside to Avro is you can't read it like a text file. You can't just open it in a text file. or in the text editor, you won't see a whole lot there. So you do need a utility to read Avro files. You can find a lot of these utilities around online. Many of them are free. There's even a plugin for Visual Studio Code at this point that'll read Avro. So that isn't a huge barrier to entry, but it's just something to think of at least. But the two really huge formats you'll see in big data and data lakes today are Parquet and ORC. So these are file formats that they're binary, they're compressed by nature. They support compression, like columnar compression, kind of like column store indexes in SQL Server, but in a file format. And Parquet was designed by Cloudera and Twitter. ORC was from Hortonworks and Facebook. Parquet is the bigger of the two, at least the one that I end up working with more frequently. But these are very efficient formats because they are compressed. It is a little slower to write to because you do have this column compression you have to calculate to write out to it. But you get some great performance benefits with these, and we'll actually see that in the demo later. Column store, of course, does optimize for reads, but it is not a solution for everything, right? You know, when I was a consultant, I can't tell you how many shops I went into doing performance checks, and the DBA or somebody would be like, well, we put it in the column store index, so it's about as fast as it can get, right? Well, probably not actually. But column store is great if you need column store, but if you don't, it's not going to do you any favors. So these file formats with this column compression, they're great for analytical workloads, but no workload is alike. Test your workload in this format and make sure it actually makes a difference. But if you're querying over data multiple times, or if you're looking to capitalize on some of the features it offers, like column elimination, which is really easy when your data is all stored in a column format, or if you need predicate pushdown and you're looking to, not return all the records you don't need, only the ones you do, that's something that predicate pushdown can really help with. That's supported by column formats like these. And also a huge thing is a lot of time with text formats, with CSV and other delimited formats, you can run into encoding issues where the encoding of the file is not what the application is expecting, right? It was expecting a UTF-8 file with the byte ordering mark, and you don't have it there, so it throws an error because it doesn't possibly know how to handle this. If you're using one of these column formats, all those issues go away because all the delimiting and the encoding is handled by the file format itself. I'm guessing there aren't any questions so far. Has anyone seen any?
Nope.
Assuming
So
not.
far
Okay.
we're good.
Everybody's mind is blown. They got no questions. That's great. Okay. So in that case, we're going to move on. We've talked about storage and we've talked about what we're storing. So let's talk a little bit about how to store it, right? Now, remember, this is a storage system. It's a hierarchical storage system. So we have real folders. And there usually is a fairly standard way to store data in a data lake. And these are called zones, and zones are just a fancy data lake term for folders. But because we have lots of data from lots of sources and potentially different versions of that data in flight, this is where organization is really key here. So a lot of data lakes will be organized into some common zone names here. We have archive, raw, reference, temp. These are pretty common, like you'll see these in a lot of places. Some organizations will create other zones as well. They'll create zones for different users or for different teams, or maybe the data scientist team has their own zone that they can play around with in their sandbox, or maybe there's a development environment which is a zone, which can be a good or a bad thing depending on how you look at it. If I told you I had a dev environment and my dev environment was a database on the production server called dev, I would probably give you some funny looks. And I've actually worked in environments like that where that was literally all we have. But of course, a better option is to have a completely separate server, perhaps on a different network as well. That is the actual development environment. So similarly, you could have multiple data lakes you could create and have one be the dev data lake as opposed to the prod data lake. That's probably the ideal solution, but if that's not an option, or if you have other reasons not to, you could create your dev or test as zones in your production data lake, though I would try to steer you away from that as best I could if possible. So the raw zone is probably the first zone and the most common one you'll see, and this is where you load data in its original state, its original format, straight from the source system. Right, so we're loading images from the healthcare system, from the radiology or whatever. This is literally, we would bring the data in its original state from that system. maybe sort it by, what particular system it came from in its schema, but that's about it. The general rule is raw data, you want it to be immutable. You do not want to alter that data once it enters the raw zone, other than maybe breaking it up by date. And the reason we want to do this is we always want to be able to trace whatever analytics results we arrive at back to raw data. This is kind of like, I kind of think of it like I do with genealogy, actually. So I'm huge into genealogy. I'm the keeper of the history in my family and whatnot. And if you do genealogy work and you're trying to figure out, when exactly was someone born, or when exactly was, did a wedding take place or something, you might come up with different data. I could tell you right now, I am doing some research on my great grandfather, and I have two different possible dates that his wedding might have taken place from, and this is going to church records too. I've seen church records where the dates are different. I'm not even sure of what his wife's maiden name was because they wrote it differently in two different places on the same marriage license application. Like, you end up with all this data that contradicts itself. Um, you want to be able to trace it back to, okay, I think I know this is true, and I think I know this is true because I have this raw data here. So with genealogy or with a data lake, the idea is you want to be able to trace your results back to, okay, this is the data that caused this to be the result. And that's what the raw zone is really for. After the raw zone, the next zone you'll probably see is like a curated zone. And this is where data is stored in a transformed state. So you would essentially copy the data out of the raw zone, transform it in some way, and place it in the curated zone, right? So maybe this is where you create your data mart or your data warehousing builds of that data. And this is generally where end users actually get their first access of the data. Like, you wouldn't let an end user touch the raw data. Pretty much the only thing that touches that data is the system that's bringing it in and the system that's doing the operations and the transforming on it to get it into a curated state. This is also where data governance takes place, right? So the data here is controlled. There might be auditing on it, hopefully, depending on what kind of data it is. It's a very flexible zone in the sense that, there could be a lot of different teams or individuals that get at this data for a variety of reasons. But this is where this is the raw, with air quotes here, data that users would actually see. This is as raw as they're allowed to see it. Next zone you might find is a temp zone. If the incoming data is mutable, and I know I just told you 2 slides ago that raw data should not be mutable, and it shouldn't, but sometimes it might be, especially depending on how you're loading data. If you have batches, or if you have like a stream of data coming in constantly and you want to do some batching on it, this is maybe where that data streams in. You create a batch or a micro batch or something, and then push it back to the raw zone at that point. For analytical purposes, that might be more efficient, depending on how you build your pipeline and all your processing. Or maybe you're looking to create deltas, change over time. So you keep a cached copy of that change over time in temp to calculate the next value with. That's another use for the temp zone. And of course, this is data that is fairly disposable. So like temp DB and SQL Server, right? If you get rid of it, it's not the end of the world. Same thing goes for your temp zone in a data lake. And then the last most common zone you'll probably see is an archive zone. This is usually where data goes when you're done with it. If you are aging data out of your data lake for whatever reason, maybe you only keep it for so many years in your organization, instead of just deleting it outright, put it somewhere else first, make sure let it there. So maybe you're required to keep it for 10 years, but you only do analytics for 5. So it'll spend the second 5 years of its existence sitting in an archive zone somewhere. Again, you can use access control and security settings in the data lake to restrict who can see the data in this zone, just like you can with anything else. But this is usually the last stop your data takes before it actually gets removed or deleted. And if you're using a data lake generation 2, which hopefully you are, you can do things like tiering within your containers, where maybe the archive zone is actually in the archive tier of Azure Blob Storage, so you're paying less for it as well, because again, ideally you're not actually accessing that data. All right, we're moving right along here. Let's talk about some processing real quick. So we talked about zones. And as I said before, and I'll show you this slide again, Azure Data Lake is designed to integrate with lots of different tools and services, right? And enable self-service. That's really the biggest idea, is this data is well organized in a place where the users who need this data can get at it, and shouldn't need a whole lot of help from you, quite frankly. It should be kind of self-servicey. To kind of show you how this would fit in to a pipeline, I actually have an image here that I stole from Microsoft because they did a darn good job of it, but they show how you have data coming in, whether it's from on-premises or the cloud or wherever, being ingested with something like Data Factory, then being stored at the bottom there in Azure Data Lake storage, at which point you can, view the model, view the data, explore it. You can build models, you can train your models, you can put it in a data warehouse, and you can visualize it all with something like Power BI. So data lake storage is kind of designed to be this common storage layer where your data can be accessed by, like I said, a variety of tools, whether inside or outside of the Microsoft ecosystem. Another thing I'll touch on real quick here is Azure Synapse Analytics. I don't know if you've seen this or if they've had a presentation on this lately. This is really cool stuff, actually. So the idea is you have data warehousing and big data analytics, and you can really merge the two. It was formerly Azure SQL Data Warehouse, which was formerly SQL Parallel Data Warehouse, if you remember the rack-sized appliance they used to deploy on site for that, and then they moved it to the cloud. And now we have Synapse Analytics, which is designed to let you, effectively join between your big data in something like HDFS and a data lake and your relational data online in a SQL Server database. That's the biggest, newest thing Microsoft has for that right now. Talk about one of the older ones we have here. We have something called Azure Data Lake Analytics, right? And this was designed only for Azure Data Lake Generation 1, but it was kind of the native language of Data Lake Generation 1. It was called USQL. It was this weird combination of SQL and C#. But probably the coolest thing about it is you could execute it locally. So you could actually go ahead and stand up an Azure Data Lake Analytics on your Windows 10 computer and run it there and not have to provision anything in the cloud. And I have a link at the end to a demo where you can try that if you want. I don't necessarily recommend it at this point because hopefully you're not provisioning anything in Data Lake Generation 1. But this is an example here of USQL syntax. So you create these things called row sets, which is what the top line is. We're defining a row set, named row set, as an extraction. So we're extracting some columns from a file. We have a TSV, a tab separated file format. We're extracting it with this extractor called extractors for TSV, and then we're defining what we're reading from the file with its data type as we're reading it, right? So we're picking the first 3 columns, those are their names and their data types, and then we're actually outputting those 3 columns to a different file using an outputter method there. So you can see it's kind of like T-SQL. If you can read SQL, you can understand this. But there's definitely some functionality that makes you think, this is kind of more like C# in some ways. So then there was another one called Hive, and this is an older but still current tool at this point, designed originally for Hadoop, and it was designed to let organizations that were adopting Hadoop get up to speed very quickly by querying their data in Hadoop using a query language very similar to SQL. So they called it HiveQL or HQL. You can see an example here of HQL. So if you understand SQL, you can read that and make heads or tails of it. That was exactly the idea. Hive is still around today. Still sees plenty of use. You can query data in an Azure Data Lake with Hive, just like you could, in anything else. So let's talk about some design considerations here, because since it is a file system, there is an awful lot of freedom in how you laid out your data lake, right? We talked about the zones, but there are issues you can run into that are fairly common. So one of them is naming. File naming is really important, especially because we're trying to enable self-service on a system like this. So you want to be pretty consistent with your file names. Have the date and the time of the data in that file in the file name along with the source. One of the demo I have here, I actually have Chicago parking ticket data in a data lake. So I have a file name example here. So this is, by looking at that file name, you can tell that yes, these are in fact parking tickets written in the city of Chicago in October of 2017, or on the 31st, actually, on Halloween. So 1 day's worth. Another issue with data lakes is splittability or partitioning. Um, if we think of a relational database as being a bunch of tables like it is, and then we say, okay, we're going to put it into a data lake. We're going to create one table per file. Well, that's a pretty terrible idea, right? Especially if your tables are huge. You start coming up with these mammoth-sized files, and that can get harder for your processing engine that you're using to query against a single file. Every engine has its own quirks and limits, and they change with newer versions frequently. But if you have in some of these systems, if you have a single file, maybe only one thread can read that file. So you get very hamstrung in performance very quickly. So you'd want to have multiple files for that. Split them up by date or by hour or by minute, depending on what you need. On the same end, having thousands of files in the same directory isn't always that great either. Usually there's an upper limit to where things start becoming, once again, constrained. So maybe don't put 1 million files in a directory, but also don't have a 10 terabyte file. Try to find the happy medium. And this is very dependent on what you're using, what MPP system you're actually querying the data in Data Lake with. Also, good ideas are don't have empty files or folders lying around. That just gets confusing very quickly. And keep your data separated by data types, right? We're talking about parking tickets here again. If I had other data that was not parking ticket related, I would not put it in the parking ticket folder structure. I'd create a separate structure for it. Makes it, once again, easier for self-service. And the way a lot of these MPP systems work is you actually point them at a directory or a directory tree, and then it will go scan everything in that directory tree. So if it has to sit and figure out, oh, should I actually scan this file or not? That's a problem. That'll kill your performance pretty quick. To show just an example of how I've partitioned my parking ticket data that once again we'll see in a demo here. I have a raw zone like I created. I have parking tickets. I then break it down by year and by month, and then we have the files per day below that. There's also splittability. So some file formats are splittable to where the engine can actually split a single file into multiple segments and have multiple nodes or multiple threads scanning those segments, which is great for performance. Compressing some files might make those formats unsplittable depending on how you compress them. But again, this varies by what engine you're using, so you really need to check your documentation. If your format is not splittable, then you totally got to manage your partitions manually, like I showed you with a directory tree in the name. You can end up with, if you don't do that, or if you do it poorly, you can end up with issues like you would with SQL Server with like a CX packet wait, for example, right? Where some threads are done before others. Now you have a whole lot of waiting going on, and overall time has been wasted. You can come up with similar conditions with MPP engines scanning data in a data lake. As I said, compression can make some formats unsplittable. Some of these formats have compression already, right? We talked about Parquet and Orc. Those have column compression in them already when you write to them, so you're already capitalizing from that. You shouldn't need any more compression at that point. Sometimes you can layer them with more compression if you really, really want to. But usually the performance benefit from a column compression format alone is enough to get you to see some dramatic results. As always, with anything compression related, right, there's no free lunch. There's a trade-off involved. So yes, you're saving storage space and memory and I/O, and that's all great. It always, though, comes at the expense of CPU, right? Anytime you have to read this data or write it, you now need to compress or decompress it. You're going to pay for it in terms of compute resource instead. All right, so let's talk about anti-patterns really quick. Probably my favorite anti-pattern, or least favorite anti-pattern, is the data swamp, right? This is a result of poor organization. There's a presentation that a lady named Karen Lopez, you may have heard of her, she had years ago talking about anti-patterns in data lakes, and it was called "Who's Pissing in Your Data Lake?" and it was awesome just for the title alone. But it was a great session as well. But she went through a lot of issues with poor organization and how that really kills usability and performance in a data lake. So yes, if you don't have standardized naming, if you don't have data governance, if you don't have catalogs where people can actually figure out what they need to get to, then you're kind of killing the whole premise of self-service access to a wide variety of data that a data lake is based on. Another anti-pattern, I kind of touched on this before, but files that are too small can actually add overhead and slow down your MPP engine. If it has zillions of very small files it has to go through, there's resources and time spent every time you have to open and close a file, right? So if you're doing that more, that's more time you're not scanning data. Optimal file size will vary per your compute engine. Check your documentation once again. I know I've said that 3 or 4 times by now. Probably one of the biggest misconceptions with the data lake is that they're just for IoT data, right? For Internet of Things data. That's a great use case for them, but that's not the only use case you would use a data lake for, right? If you have lots of data in a relational database, if you have historical data that doesn't really need to be in a relational database anymore, right? This is where you can really integrate the two, right? We have big data clusters, which is kind of the on-premise version that will let you join data between a relational database and a data lake. We have Azure Synapse Analytics I talked about. That's kind of the cloud version. We have Polybase, which has been around in various versions since SQL 2016 or 2014 now, where you can essentially virtualize your data and attach SQL Server to an external data store and treat it as if it was relational data in the database. So you have all these tools now that have come out that let you integrate your relational data in your non-relational data, and they're pretty seamless at this point. So that's all awesome. But yes, it's not just IoT data streaming into a data lake anymore. So let's talk about DBA topics here. I'm a DBA at heart first, so probably the first question I ask when I see a technology, right, is how do I back that up, right? So how do you back up your data lake? Well, there's not really a great story for backups at the moment. I mean, you would have to do something like create another blob storage account and then copy the data over there, right, with a tool like AZ Copy or some other utility. You could use higher redundancy settings and have your data automatically flow to a different region, and that's great, but not all disasters involve, the data center going up in flames, right? Much more common disaster scenario is, oops, I didn't mean to delete that. And if you have any kind of replication going on between data centers, well, that doesn't solve that problem. But you can, manage your redundancy, and you could copy it off to another storage account or do something like that. Though if your data lake is in the terabyte or petabyte size, that would be a formidable process at that point. How about indexing, right? Where we're DBAs, we like to performance tune, hopefully. Indexes are kind of a bread and butter database administration skill, but there are no indexes in Azure Data Lake, and that's simply because it's a storage system, and indexes are not a storage feature, right? They're a compute feature. So that's not something that Data Lake provides, nor should it, I would argue. As we talked about, some of these column compressed formats, they do support indexing, but that's the file format that's doing that. That's not the data lake, not the storage system itself. But usually the indexing would take place as part of your data warehousing platform, as opposed to the actual data lake engine itself. Use SQL, the language I showed you a tiny bit of there, it does have a create index statement, but basically all it does is sort your data set by whatever column you tell it to sort by. So it's kind of like a clustered index, but probably not going to help you. So what development environment should we use for a data lake? And again, this heavily varies on what tool you're using. There is no SQL Server Management Studio or Azure Data Studio for a data lake. So depending on what you're using, you might use Databricks notebooks, you might use Power BI, you might use Azure Storage Explorer just to see what's in your data lake, or it might work with Visual Studio. There are some plugins for Azure Data Studio that would let you browse your data in a data lake, but that's not, the key feature of it is just one of the plugins that's available. So the development environment really depends on what tool you're using, and the data lake itself really doesn't have a development environment because, again, it's a storage system, so it's not like you're developing for the storage. So if you'd like to get started with Data Lake, probably some easy beginning projects I could think of to kind of, dip your toes into the Data Lake. Like I said, um, use it as a staging area for data warehousing loads, or offload archived or unused data into a data lake first. Make use of that archive zone we talked about, or start a net new project and have that project ingesting through a data lake as opposed to some other process like SSIS or something like that. So with that, let's do a demo here real quick. So I'm going to go ahead and I'm going to show you what I have. So let me pop up onto the screen here. This is Azure Storage Explorer, and I apologize if it's small. I don't know how to make this one look bigger. So Azure Storage Explorer is a utility for any Azure storage account. You can basically just pull up your storage account, sign in Azure with it, and see all the data that you have in your storage account. So I have this ADLS Gen 2 account here. And essentially, this is, like I said, City of Chicago parking ticket data. So I have parking tickets in Chicago going from the years 2003 to 2016. There's like 37 million parking tickets in this data set I have here. And it's broken down by year and by month and then by day. And it's all just CSV files. So I apologize if that's a little small and you can't see, but that's literally what my data lake consists of. So with that, I'm going to go ahead and drag over to the window here. This is Azure Databricks. So this is basically an environment. I have a cluster running, consists of several machines running Apache Spark, and I'm able to write queries for Spark in PySpark or Python, essentially, to query the data in this data lake. Now, I've already gone ahead and I've already attached this to my data lake. And I've done two things with it. I attached it and I created a copy of the data lake in Parquet. So essentially I have two copies of all these parking tickets at this point. I have a copy that's just sitting in straight up CSV files, and I have a copy that's sitting in Parquet files. So what I just did here was in this notebook, and if you haven't seen notebooks yet, they're awesome. They allow you to combine effectively text and code and execute that code and save the results in a JSON document is what it ends up being. So I have a query here I just kicked off, and what I'm telling this job to do right now is go ahead and count all of the parking tickets I have in the CSV files. So essentially, it has, like I said, from 2003 to 2016. So that's what, 13 years of parking tickets at one file per day. So multiply 365 by 13, and you'll come up with the number of files that this system is currently scanning through to count the tickets, right? This is not a fast process, just like if you had a heap in SQL Server and you were trying to count the number of rows in a huge table, SQL Server would be doing the exact same thing. So here we go. This actually took a total of 55 seconds, it says, and it returned 36.7 million tickets, parking tickets I have in this database. So now that we've done that, I'm going to go ahead and kick off this second job here, which is going to do the same thing again, except now it's going to scan the Parquet data instead of the actual CSV files. Now there's still multiple Parquet files in play, but again, they're compressed, they're indexed with a column store much faster, right? So I was able to get the exact same result, but this time it only took 12 seconds is what that took. If you'd like to see kind of what this data looks like, we can run the show command. And this will just grab me the first 20 records in this database. We can see here, license plates, where these cars were parked, what they were ticketed, what their violation was, how much the ticket cost, whether or not it was paid. It was actually a very entertaining data set to look through. And if anyone on the call here has gotten a parking ticket from the city of Chicago between the years of 2003 and 2016, and you want to look up your license plate, you could actually do that, or I could do that for you if you want to shout one out. But that's what you can do. And then we have Spark SQL essentially, which is a language where you can write a SQL query in Spark and execute it, and it will work. So like here I have just a basic aggregation query, select the car make and group by that. So give me the number of rows or number of tickets per car make. Who has more tickets, Chevy or Ford? Well, actually in Chicago, Chevy had more tickets than Ford, followed by Toyota, Honda, and Dodge. So there you go. We have this data set. If anyone wants me to look up their ticket, I will happily do that. Otherwise, you're feel free to grab the data set yourself because I have it available for download here. So did a brief little demo just showing how you can query the data lake in Spark. What's it cost? Let's talk about pricing here. So in Azure Data Lake Generation 1, which again, you don't want to use at this point unless you have a real reason to use it, you pay for storage, right? So you pay, it's about 4 cents per gigabyte per month. You pay per read and write operations. You pay about a nickel for every 10,000 reads, 4/10 of a cent per 10,000 writes. And then if you're doing data transfers, transfer outbound from the Azure region back to your network or wherever you're reading from, you always pay for data out as well. It's about 8.7 cents per gigabyte last time I checked the price, but that varies by your region. So, and this is all central US region is what I based it on. That's generation 1. Generation 2, you get a different pricing structure because again, you get to pick your storage tiers and that changes your price, right? So you pay for storage once again. And this price is actually, I can tell you right now, this 0.002, that's the, 0.002 was the archive price. So we're going from the hot, the cool, and the archive price. Those are the 3 prices you see. So storage goes down, right? Archive price gets cheaper. Read operations get more expensive. It costs a lot to read from archive storage. Look at that, $6.50 per 10,000 reads from archive storage. But price goes down to store, goes up to read, whether you're from when you're going from hot to cool to archive storage. These are cheaper than those prices I just quoted you before for generation 1 because generation 2 is designed to be cheaper. If you'd like to play around with this for free, like I said, there is a tutorial at Microsoft you can get for running uSQL and actually setting it up on your machine if you'd like to try that. There's also an Azure Databricks free trial you can do through Azure if you'd like to try something online in the cloud. I have a whole bunch of resources here, articles written by people. I have my link to my Chicago parking ticket data if you'd like to download that and play around with it yourself, be it in a data lake or just in a database and see what you can find. Have good stuff like that. I also have at the very end here highlighted, if you go to bobpusateri.com/r/dipping your toes, that will take you to my GitHub. And from there you can see, you can get this slide deck, you can get all the demos I showed you, all the materials, it has all the links, basically everything is there. So at this point, I don't know if anyone has any questions or not, but if you're looking for my contact information, again, it's right up here and I'm happy to answer any questions you might have.
Hey, Bob, this is Jared. There
Hey.
was actually a question. I gave it an answer that I would give, but since you're the speaker, I wanted to make sure you had a chance to answer it as well. And so Jessica was asking, what's the difference between a data lake and a data warehouse? She's guessing that a data warehouse is where you store structured data.
That's how I would define it, at least, Jared, right? Is that what you would say too? I mean, that's my definition of, if you have, relational data, if you have a predefined structure, then yes, that would put that in something like a data warehouse, as opposed to a data lake is really for unstructured ad hoc data that is organized but not in a relational format.
Yeah, I would agree. The typically non-structured, you can have, and I'll just be nitpicky, Jessica, with when you said structured data, and you'll notice Bob said relational, because oftentimes our JSON or our Parquet is in fact, quote, structured, but not relational. And so usually, yeah, the data lake is for that. Non-relational, oftentimes unstructured data. And many times you'll actually load it into a data warehouse to work with it, and then maybe you'll dump it out, or you'll store it there once you've taken it out of its raw format, because sometimes you can only get data in a Parquet format or in a CSV. For instance, a lot of this COVID data is coming from different sources, and sometimes it's in text, which really CSV is just, it's another word for text, because it's oftentimes not even comma delimited, it's pipe delimited. But then Parquet, Avro, depending on how they write out the data.
And I guess beyond that, Jared, I'll just add because I forgot to touch on this point. If you're watching this and thinking, "Oh, this is really cool," this is something I want to get into. Maybe we can get rid of our relational database and put it in a data lake. No, don't do that. Right? This is a completely different solution for a different type of problem. So this is not I should be getting rid of my database tomorrow and move my stuff to here. Like some of your stuff probably could go here and do well, but if you have data that's in a relational database right now and it's working well for you and it's not, tons and tons of effort to maintain and transform data to get into, I would keep it in my relational database. Absolutely, it's relational data at that point. So
Yeah, Bob, I've got a question for you actually, because I
right here.
haven't worked with Data Lake as much as I'd like to. But I noticed that when you set up a storage account, you choose the hot or cool access tier. But that's just a default. So all the way then we've got containers, right? And then we've
hmm
got our folders, and then the files. So at which levels do you know can you set the access tier? Is it all the way down to the file level for all tiers, or is it at the folder level, or is it at the container level?
You can set the access tier at an object level, right? So any individual file or object you write in a blob storage, you can say put it here with this access tier, or change its access tier after the fact. The default applies to, and I can't remember if it's the account or the container right
It's
now.
the account because I
It's the
just
account. Okay. Okay. So it's the account. So basically anything you write to that account will have this default unless you specify differently, right? And you can actually specify when you write it for the first time, put this file in here at this different access tier. I do that all the time through Azure CLI or through PowerShell, to write specific files because I have my account. I think the one I use, at least for my personal storage, I have it set to cool, but then I usually just write stuff to it in archive anyway. So very rarely am I actually using the default access tier.
okay, cool.
So cool.
No more questions.
No more
I
questions.
did want to just throw one more thing out there. Bob was talking about indexing and how we don't really index the data, but what's really cool about the hierarchical namespace that makes this a data lake, and I just found this out yesterday from a colleague of mine, is that the folder structure, so this whole idea of a hierarchical namespace, is indexed within the data lake. So to traverse those folder structures can be very fast. And so what I took from that is that when you get down to a folder structure, to choose your folder structure is really based upon the smallest set of files or file that you would query at a particular time or that you would load at a particular time. Because that's where the index level lies, I believe, is at the file level or at the folder level, not necessarily the file level.
That
So,
is my understanding as well, as it's indexing
okay,
the folders, but not the files that are in them.
right. And so,
Yes.
so oftentimes you'll see, at least in a lot of the demos and training that I've seen, you may see a folder that only contains one file. But for that particular use case, it works for that. Um, and so just kind of the design of the data lake, which is a whole other discussion and probably an hour-long topic as well, is really something to consider when you're optimizing for how you're going to read the data and how you're going to load it.
Good point. I see Ross threw a license plate number into the chat, so I'm going to look it up right now and see if we can find any dirt on Ross here, if there's anything. Real quick.
The other thing I'll just mention to people is if you're going to play with this, it's kind of weird to make it a Gen 2 because, or I'm sorry, to make a storage account into a data lake because the option, like it doesn't say make this a data lake. It almost looks like the hierarchical namespace is an option under data lake storage Gen 2. So just so you know, by enabling hierarchical namespace, you are in fact making your storage account a data lake. It's a little bit weird. I don't know why they did it that way. But that's the way it does. So as soon as you enable hierarchical namespace when you're creating your storage account, you've automatically turned it into a data lake Gen 2.
Yeah. I wonder if they did that in case there's other products in the future that want to use a
Yeah.
hierarchical namespace, and then they don't got to go back and rename everything.
Yeah, could
So,
be. Yeah.
and Ross, it looks like I got a ticket here for that car from 2009 for rush hour parking for $100 that was paid. I don't know if that's
Oh,
accurate or not, but
Yeah, and
gosh.
that was just the beginning of the pain point.
oh really?
Oh yeah, it was towed, and
Oh man.
what a mess.
I'll also let you all in on the little secret that Brent Ozar used to live in Chicago, and his license plate was his Twitter handle. So you can look up him here and see he's got 4 of them for expired meter, no city sticker, etc. He paid them all, but yeah. So anyhow,
We've got a couple more questions here.
oh really? Okay.
One is when you say columnar storage, is that the same as Vertipack, for example?
It's the same idea as Vertipack. I pretty much guarantee you it's not the same implementation, but it's the idea of, yes, you're breaking the data up by columns and compressing ranges of data in them that way.
Got another question here. A data lake without a very well maintained catalog becomes a data swamp very quickly. So how do you suggest we manage the catalog?
Yeah, these are data governance questions at this point, right? This is where this is a process problem. And I used to work in healthcare data, and we had a lot of time spent on data governance and organization for this very reason. We had data from all kinds of different units of the healthcare system that we had to keep straight and keep track of who had access to who had research IRB requests in, and who was allowed to see what. So this was all part of that catalog that we had people who maintained it, literally to keep track of that all. So if that's all we got for questions. Sorry, it was a little shorter than I thought it was going to be, but we keep it moving here when we do virtual presentations, right?
Looks like we got another number here.
Oh, another
93
license plate?
Yeah,
Ha 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 ha.
930-7413.
307413. Let's see what we got here.
That's
And you'll notice
Jared's.
that's Jared. And you'll notice these queries are not instantaneous, right? This is not a sub-second return of a query like we'd expect from a database, right? That's because this is usually for more analytical purposes, where we're combing through tons and tons of data over a period of time. Ooh, we got 3 here. Jared, your Toyota. Street cleaning.
That's my old Toyota and my old address, but now I want to see what Isabella's got. I put her plate in there. I want to see if she's got more than me.
Ha ha ha. Uh-oh. Hopefully she's not watching tonight. All right,
No, she's
zero,
not.
02. Let's see if we got anything here. So yeah, it's a great data set. I put it up on my blog a while ago, and I've had different people download it over time. I had one guy who's a professor somewhere be like, "Yeah, I use this for my class. My kids get a real rise out of it." Okay, looks like there's definitely more tickets for that license plate, Jared.
Yes, but I fought 3 of them and won.
There you
Yeah, they were
go.
dismissed. Yeah.
Nice.
But that was 4 legit, so she still got me beat by 1.
Wow.
So I'll have to give her some flack for that.
At least you got the $200 ones dismissed.
Yeah.
Nice.
Who's to say that I didn't park her car though? That's the problem. So
there we go.
All right, well, cool. Any other questions for Bob? We'll wrap this up at 7 o'clock.
All right.
So thank you so much, Bob.
Yeah.
For
Thanks, Bob.
Thanks for having me. Thank you all for coming tonight. I appreciate the audience.
Yeah, everybody, we're going to be kind of building on some of this stuff on different presentations. So keep your eye out on what the speakers are going to be speaking of. I mean, I even know even though it's a ways away, I'm going to kind of build on what Bob has done here and do Synapse Workspaces in March. So,
Okay.
but there's going to be some other stuff in between that's probably going to deal with some more Azure and maybe even machine learning and some other stuff. So everybody stay tuned.
Yeah, data science, that's the big thing now.
Sure is.
Yeah, really.
And data lakes, I mean, that just falls right into
That's kind of your building blocks for that.
yeah, absolutely.
Yeah, I feel old now because now there's kids graduating college who've studied data science, and that was not a thing when I was in school yet. So, grr. But
Yeah, when I started, we didn't even have computer science in schools.
oh, really?
Yeah, it was you'd go on the engineering side of things, get a say civil engineering, and there was programming classes that they would teach. Yeah, I went to a computer school.
Yeah,
Huh.
data science is just purely practical statistics. It never used to be in my day.
Got a fancy name there.
Yeah,
All right,
yeah.
everybody, I'm going to stop the recording. Feel
All right,
free to
folks.
sit here and chat, but I'm going to stop the recording.
Yeah, I
Everybody
actually
have a good night.
I gotta
Thanks.
run as well. So, but thank you all so much for attending, and see you again sometime.
Great. Thanks, Bob.
Okay, thanks, Bob.
Take care, y'all. See
Night,
ya.
everybody.
See you.
Thank you.
Bye.